So next next chapter is on polynomials. Polynomials is, well, actually, let's just get to the title screen here. This is section, come on, this is section 3.1. So it's the first section of chapter 3, and we're looking at how polynomials look. And in particular, what we're going to show you in this chapter is how to use algebra tiles to help you out with polynomials. Some of you from grade 8 may have figured out how to use polynomials without algebra tiles. Here I'm just going to show you the tiles. You can use them if they help you, but you don't have to. It's just another option. So, what are polynomials? A polynomial is an expression. An expression, remember, is an algebra sentence without an equal sign. So it's an expression where the exponents are whole numbers. And the terms are separated by a positive or a negative sign. And the exponents must be whole numbers. So here's what I'm talking about. Which of the following would be polynomials according to the rules that I just told you up here? Okay, 5x cubed plus 12x. When you see something like that, that's an expression. There's no equal sign. And let's look at the rules about whether it's a polynomial depend on the exponents. Is the exponent a whole number? Like 0, 1, 2, 3, 4. Yes, it is. It's a 3. What about this exponent here? Well, x has a imaginary 1 exponent, so it's a whole number, and so that means it's good. That is a polynomial. Yes, it is. This one here, again, there's the exponents. They're whole numbers. So yes, that's also a polynomial. Now here, the exponent is not a whole number. It's a decimal, and so it would not be a polynomial. What about these guys here? Would 3x squared be a polynomial? Yes, it would, because again, the exponent is a whole number. Here, this is not an exponent because it has to be actually a positive whole number, not negative. Okay, so if there's a negative exponent, it's not a polynomial. You haven't learned this yet, but square roots technically have fractions as their exponents, and so this one here is not, sorry, the reason why this one is no is because the exponent is negative, and this one here is not because, yeah, you can't square root a variable. And also, this does give you technically a fraction exponent, which you'll learn later. Now this one here, you think, okay, well, it's a whole number. The exponent is a whole number. It should be an expression. But do you remember what happens when you have a squared thing in the denominator? This is not a polynomial because, if you remember before, when you've got a variable in the denominator, its exponent is actually negative. So this, in reality, this is supposed to be 6, and then because this is in the denominator, it's x to the power negative 2. So in a previous lesson I showed you that negative exponents, if you want to make them positive, you bury it underneath in the denominator, but in reality it is a negative exponent. So just like here they showed you 1 over x is the same thing as x to the negative 1 exponent. That's why it's not a polynomial. Now here, there's a square root sign, but it's only square rooting the number, not the variable. So the variable still has a positive 6 exponent, so it should be good. And it is a yes. Okay. Degrees, coefficients, and constants. Here's 3 terms here. The coefficient is simply just a number in front of the variable or the term. It's just a number. So, what are the coefficients here? The 5, because it's in front of the x, and the 8, because it's in front of that x. So the number in front of the letter, in front of the variable, is a coefficient. The degree is when you look at the exponents that are attached to the variables, is the sum of all the variables exponents in a term. So this is what they call a term. This is what they call a term. And that's also another term. Now in here, in this term, if you add the two exponents, you would get 6. So we say the degree on this term here is 6. What will the degree on this be? Well, again, oh, and don't forget, a variable without an exponent has an imaginary 1. So this y here has an imaginary 1 exponent. So what would the degree on this term be? It would be the 2 plus the imaginary 1, which is 3. This does not have a variable, so you don't have to worry about its degree. Now, the degree of the entire polynomial is given as the highest degree. So we would say this polynomial has a degree of 6. So whatever the highest number is in the thing. And again, the 7 doesn't have any variables, so it's got a degree of 0. And again, the degree of an expression is the one with more than one term will be the degree of the term of the largest degree. So, bottom line, what I just said, we look at which of these terms has the highest degree, and this one here had a degree of 6. So that means the entire expression has a degree of 6. Constant, yeah, so the degree of the whole expression will be the largest degree among all the terms, which is 6, like I just said. The constant is just the plain old number with no variables, just the number. And the constant here is 7. Okay, let's play around here. For this guy, what would the degree, the coefficient, and the constant be? Okay, so we take a look here. And the degree of this first one is 10 because, remember, what's the degree of this term? Remember, x is an imaginary 1, so 1 plus 9 is 10. That would have a degree of 10. This one has a degree of 4 plus 2 is 6. And this doesn't have any letters, so it doesn't have any degrees, so the highest number is 10. So the degree of this is 10. What is the coefficient? Or I think constant is what we'll do next. The constant would be 12. It's just the number by itself there. So that's 12. And the coefficients, remember, coefficients are the number in front of the variables, in front of the letters. So you'd have -7 and 11. So the constant is 12. Remember, constant is just the number by itself, and the coefficient are the numbers in front of the variables. This one here, now when you look at this for the degree, you see that exponent there, but remember, degrees, you only look at the exponents of the variables, of the letters. That's just 8. They're just playing tricks on you there, so you don't even worry about that. The degree of this term is 7 plus 4, 11. The degree of this term is 5 plus 1, imaginary 1, which is 6, plus 6, 12. So the degree should be 12, and it is. The constant, is there a constant here? Well, that's got a variable, and that's got a bunch of variables, so there is no constant. And the coefficients are the numbers in front. Well, what is the number in front here? 8, and the number in front, you don't have to figure out what it is. It's negative the square root of 82. Okay, these two down here, we're not going to worry about. We'll show you how to handle these guys later on. So let's skip them. Move on to naming polynomials. There's 3 types. Monomials, like these guys, where there's just one term, one thing. That's one thing. So those are all just one thing. Yeah, that has a whole bunch of things, I guess variables in there, but they're all multiplying each other. To know the difference between a monomial and a binomial, bi means 2, binomial is when you've got a plus or minus between the terms. So these are individual terms, monomials. If you have a plus or minus between them, then you've got a binomial, like 5x plus 7. 1, 2 terms. This chunky thing is all 1 plus 1. Now it's got 2 terms. And that minus that, 2 terms, so it's a binomial. Trinomials are obviously 3 things together, so like 1, 2, 3 terms, 1, 2, 3 terms. So the biggest thing, people think that's like 1, 2, 3, 4 terms. No, because they're all multiplying each other. That's like one chunky term by itself. And the terms are separated by plus and minus signs. Kind of like a term is a word, or a phrase, I guess, and then the plus and minus are like little commas or periods, breaking it up. Okay, now, drawing polynomials, using algebra tiles. You may have used these before in elementary school, or maybe in grade 8, not with me. I didn't use them in grade 8, but let's use them now. When you've got these little rectangle shapes, a yellow rectangle, that's referring to the variable. Normally it's x. It doesn't have to be x. It could be x, y, z, a, b, c, g, f. It could be whatever the variable is. So a rectangle is x. So we would call this 1x. And if you've got 3 rectangles, that would be called 3x. Now, if you've got a square like this, we call that an x length times an x length, and an x times an x, just like a 5 times a 5 is 5 squared, x times an x is x squared. So rectangles are just x's. The big square is an x squared. And the little cube squares, well, not cube squares, the little squares are just individual constants. That's just 1. Because actually these things are all based on little square blocks. And this has an area of 1, that's got an area of 1, so 1 times 1, that's 1. So the little squares are just the constants. So if you've got 1, 2, 3, 4, 5, 6, 7 constants, that means that's going to be called 7. Okay. If you have something like this, you've got 3 of these x squared, so you'd call that 3x squared. Okay, so just getting used to the terminology here. You may need to pause, rewind, and rehear this. But basically, rectangles are x's, squares, the big squares, are x squareds, and the little tiny squares are just the constants. You just count up how many there are, and that's how many there'd be, because the constant terms. Okay, let's take a look at this. What would this diagram be showing you? Remember, this is an x squared, so that's x squared. These are x's, there's 3 of them, so 1, 2, 3, it's 3x. Now the yellow ones are positive. You may remember, if you've done algebra tiles before, there's yellow and red tiles. The red tiles are negative, so that's why they put a negative sign there. So that's positive x squared because it's yellow, positive 3x because it's yellow, and now we have 1, 2, 3, 4 red little squares, so it's going to be negative 4. Let's try this one here. What would this be? Okay, you've got 3 of the big squares, and those are the x squares. You've got, and usually you go in order. You go the square thing, and then the x's, and then the constant by itself. So I know it's tempting to want to count this next, but actually we're going to count the rectangles next. They're red rectangles. Red means negative. It's like these were negative 4. These are negative. But these are x's, so you're going to have negative 2x. They're being fancy by doing the plus there, but really it's just in minus 2x. And we got 1, 2, 3, 4, 5, 6, 7, 8. 8 of these yellow positive constants, squares. So what's that? 3x minus 2x plus 8. Just ignore what they did there. Just put a minus sign there. Okay. Here, now, if you remember, and I put a little note to myself, 0 pairs. If you remember how to deal with 0 pairs, when you've got a yellow and a red, they kind of cancel each other out. They neutralize each other. So these two are going to neutralize each other, or actually those two. And some of these little small reds are going to neutralize and cancel out some of these other yellows. So when you do that, what are you left with? Those two neutralize each other. 3 of these will neutralize 3 of those. Like that. And they're gone. And what are you left with? X squared. Red means minus 2x. And we have a positive 5. X squared minus 2x, positive 5. And again, they're just being extra fancy here. That just means x squared minus 2x plus 5. Alright, so again, like I said, 0 pairs, or whenever you add a pair of negative and is when you have a negative and positive canceling each other out. Plus 1, minus 1 is 0. Plus 1, minus 1, 0. Those are just 0 pair. Same thing here. Plus 3 to minus 3 gives you 0. And the same thing with x's too. You can have 2 x's, 2 red x's. They cancel each other out, giving you 0. Okay, now, what about this expression here? Right here. Oops. Not letting me. Okay, this expression here. Simplify the following expression. So, let's have the yellows and reds cancel each other out. These two yellow and reds cancel each other out. I'm guessing these two reds are going to cancel out those two yellows. And these 3 reds are going to cancel out 3 of these yellows. And they're gone. And what are you left with? X squared plus 2. That's it. There's no x's left. No rectangles left, so just x squared plus 2. Okay, here, let's see what you got. Let's match these guys with these expressions. 5x squared minus 3x plus 1. Which of these is showing that? Now these expressions over here have not been cancelled out. So here, let me just draw this one, you'd have that one cancelling out with that one cancelling out with that one, which I do not these red, whatever, and then you're left with a negative 2x squared is left behind, those two there, and then you've got these two cancelling out with those two, and these 3, cancelling with these 3. And so what are we left with? Well, we got the negative 2x squared. We got 3 positive x's. And we're left with 3 negatives, minus 3. Which one of those is that one there? Negative 2x plus 3x minus 3. That one is A. How about this one here? Does this one match up with anybody? This would be positive 4x, so it could be this one. And then we've got 1, 2, 3, 4, 5, 6, 7 negatives, and a second negative x's. No, none of these, so that one is not that one. Let's keep looking for who this could be. Could it be this one? No, that's not right. How about this one here? Nope. Could it be this one? 1, 2, 3, 4x squareds. So it could be. That's a 4x squared. And then these two are going to cancel each other out. And you're left with 3 negative x's. And you're left with positive 3. So that is that. So again, this one is A. This one here is going to be D. How about this? Negative 2x squared. Which one? Looks like it's going to be 2 reds left behind. Looks like this one here. This one has 2 extra reds. You cancel that out with those. You've got negative 2x. One of these positive x's cancels out with that. You're left with a, so we have negative 2x squared here, plus an x, and then 3 of these cancels out 3 of those. You're left with negative 3 here. So f must be this one. And for this one, the 5x squared one, you can see what it is. I'll just let the computer show you. It'll be that one. Trust me. Like I said, that one's there. That one goes there. And that one goes there. All right, forget that. This is, now get in the habit of drawing algebra tiles. Even if you don't have the computer doing it, you can still sketch them out. Instead of reds and yellows, if you don't have reds and yellows, just go black and white. So how are you going to show negative 5x squared? Well, you're going to have 5 of these x squared things. 1, 2, 3, 4, 5. And they're all going to be shaded in. I can do it in red. I'm not going to do it in red. For you, I'll shade it in. You can just show your negatives like this. Shaded in squares. Shaded is negative. That's negative 5x squared. Now, what about b? Well, what did I say about b's and x's and all these things? They're just variables. They don't have to be, these things don't have to be x's or x squareds. It could be b squareds too. So it's the same thing as saying x squared. X, b, g, f, flipper, shoe, whatever you want. So it's a positive 3b, so we're going to put 3 big squares to show that they are 3 b squares. Negative, which means red, or shaded in, rectangles. And then plus 6. 6 little squares. Done. Okay. Here are your skill testing questions using our good friend the algebra tiles. For this one, you got to tell me what the coefficient, variable, and degree and constant are. This one, you got to draw out what this looks like. And then here, again, the yellow, unshaded being the yellow, and the shaded are the red negatives. What would this expression be? All right. Have fun. Bye.